Welcome to the 7th chapter of our video tutorial series, where we further explore the capabilities of the Crossroad Generator tool for Unreal Engine 5. In the previous chapter, our focus centered on landscape deformations. We walked you through the proper utilization of the landscape module, detailing how to create precise terrain deformations. Additionally, we showcased the effective projection of roads onto existing landscapes, highlighting the seamless integration of road structures with the natural terrain. Along the way, we addressed potential challenges associated with landscape deformations and provided valuable insights on navigating and overcoming these obstacles. In this chapter, we will discuss the Procedural Content Generation framework, commonly known as PCG. We'll demonstrate how seamlessly you can integrate this framework with our Crossroad Generator to efficiently populate your levels with foliage or any custom assets. This collaboration streamlines the level building process, allowing for faster development with minimal effort. Leveraging the procedural capabilities of PCG, you can achieve unique and diverse aesthetics. Furthermore, we'll showcase how you can easily integrate high-quality assets from the Quixel Megascan Library, enabling you to elevate your project to cinematic quality in a matter of minutes. To begin working with the Procedural Content Generation framework, you need to enable the plugin in the project's plugin settings. Go to the main menu, click on Edit, select the plugin option, and in the search bar, type Procedural. Ensure that the PCG plugin is enabled. Now, create a new folder and name it PCG. In this folder, right-click and select the PCG rollout menu, then click on PCG Graph. Let's name it PCG Foliage, for instance. Double-click on the newly created graph to open the PCG Graph interface, where you can create nodes. Keep the graph window interface open and drag the window menu to the main toolbar. This way, you can easily switch between these windows to observe real-time changes in the editor while adding PCG nodes to the graph. Navigate to the Blueprint folder within the Mesh folder of the Crossroad Generator content folder. Drag and drop the Crossroad Generator blueprint into your editor to create basic Crossroad. Choose the Crossroad you want to work with. In the Spawning Road settings, click on Spawn All Roads to add some roads to the Crossroad. Select the Crossroad, and in the Details menu search bar, type Tag. You'll see that the Crossroad has a default tag array named Intersection. This tag will serve as a reference for the PCG graph, helping locate specific actors in the editor. Tags are crucial, as we'll demonstrate later in this tutorial. For example, if you select a road, you'll see it has a default tag named Road. Next, drag and drop the PCG graph into the editor. Adjust the size of the PCG box gizmo to ensure it covers the entire area of the targeted road structure. Also, make sure the PCG box gizmo intersects with the landscape. Ensure you've completed all these steps before we begin building our PCG graph, otherwise, it may not work correctly. Now, move to the PCG graph window and add our first node, named Surface Sampler, by right-clicking onto the graph area and typing Surface. Expand the input node, locate the landscape section, and connect it with the newly created Surface Sampler node. To help visualize what's happening in the editor, enable the debugging option in the Surface Sampler node. If you see a small blue dot in the left upper corner of the node, the debugging option is enabled. Additionally, you can toggle the debugging mode on and off by pressing the D key on your keyboard. You can do this for each node in the graph. This will create simple box helpers that represent future scattered assets in the editor. Let's go back to this Surface Sampler node and adjust some settings to increase the density of scattered boxes, simulating a grassy area. Set the points per square meter parameter to 50, and adjust the point extents parameter to 10 in the X direction, 10 in the Y direction, and 20 in the Z direction. After making the adjustments, you can observe that the scattered boxes are now much denser within the area covered by the PCG gizmo. Disable debugging for this node momentarily. Now, let's add another node called getActorData. In the settings of this node, under Actor Filter, choose the option All World Actors. Keep the Actor Selection option set to By Tag. In the Actor Selection tag, replace None with Intersection and also enable option Select Multiple. Connect this node to the Surface Sampler node by dragging the output pin into the graph area and type in Surface Sampler. This will also create a filter node in between. Set the target type to any in the rollout setting menu of this filter node. Note that we are using Unreal Engine version 5.3, and in older versions, you might encounter variations in nodes due to ongoing development and improvements from Epic Games. In this node, set the points per square meter parameter to 10. Then set point extents parameter to 10 in the X direction, 10 in the Y direction, and 20 in the Z direction. Enable debugging for this node to observe its effect in the editor. You can now see debugging boxes scattered only on the surface of the crossroad. This step is crucial for identifying the surface area covered by the crossroad, allowing us to exclude it from scattering. By adding a difference node to the PCG graph, we can remove the scattered items inside the crossroad. Connect the source input to the output of the first surface sampler node. Then connect the difference input to the output of the intersection sampler node. This will subtract all the scattered items inside the crossroad. To visualize this, enable debugging only on the difference node. Before checking it in the editor, let's add one more node called Bounds Modifier, which will help us control the border around the crossroad if needed. Also, switch the density function to binary in the difference node. Double-check if debugging is enabled only on the difference node to ensure correct results in the editor. Now, when we switch to the editor view, we can see that the crossroad is excluded from the scattering. This ensures that no foliage, such as grass, will appear on the paved area of the crossroad. Let's do the same thing for all roads, but this time, we'll use a different node called getSplineData. This node grabs information from the mesh actor that shapes the roads. Set up this node by choosing All World Actors in the Actor Filter settings, keeping Actor Selection as by tag. Replace None with Road in the Actor Selection tag, and make sure to enable Select Multiple. Connect this node to the Spline Sampler node and increase the subdivisions per segment from 1 to 10. Now, let's bring in another node, the Bounds Modifier. This node helps us set the road borders along the spline. Next, link the Bounds Modifier node to the Difference node. Within the Bounds Modifier node, adjust the mode parameter in the rollout menu to include. Set the minimal bounds parameter in the X direction to -100, in the Y direction to -280, and in the Z direction to -100. The maximal bounds values should be the same but not negative. As evident now, the roads have been successfully excluded from the scattering process. Regardless of any modifications to the roads, the PCG will dynamically recalculate the new road shapes and positions, ensuring that object scattering is adjusted accordingly. This proves particularly valuable when extending roads or incorporating additional infrastructure, as the PCG automatically handles future corrections. You can proceed with confidence, knowing that the system adapts seamlessly to changes, sparing you the need for manual adjustments. Now that we have the basic setup, it's time to test it with some foliage assets. Let's incorporate a couple more nodes. First, add the Transform Points node and do not forget to activate debugging for this node. This addition enables us to inject some randomness into the future foliage. For now, let's focus on setting two values in this node. We'll adjust the rotation max parameter to 360, allowing for random rotation of scattered foliage throughout the entire area. Additionally, we'll increase the scale max parameter to introduce slight variations in foliage sizes. Let's check these changes in the editor. To spawn static meshes instead of the current debugging boxes, integrate the static mesh spawner node. By adding the array in the section mesh entries, we can define the static meshes to be spawned in place of the debugging boxes. In this demonstration, we'll showcase how to integrate high-quality foliage assets from the Quixel Megascan Library, conveniently accessible within the editor through the Quixel Bridge plugin. The extensive library features a diverse array of 3D plants, allowing you to select and download assets that best suit your project. To begin, navigate to the main editor menu and open the Quixel Bridge plugin. From there, effortlessly search for the desired foliage or any other asset, and seamlessly import it into your project. Once you've downloaded the preferred foliage assets, return to the PCG graph and locate the static mesh spawner node. Add the downloaded foliage to the static mesh parameter in the descriptor section of the mesh array entries. This step ensures that the PCG system incorporates the specifically chosen Quixel Megascan foliage assets into your project, enhancing the overall visual quality and realism of the environment. To enhance the visual appeal of the grass area, consider adding more elements to the mesh entries array within the static mesh spawner node. Populate these elements with various foliage variations to introduce diversity, with each variation being randomly scattered across the entire area. In the descriptor settings of each entry, you can configure essential aspects such as collisions, material properties, and lighting properties for the respective foliage. One noteworthy setting to highlight is the weight parameter. This parameter allows you to control the distribution ratios among the different foliage variations. Increasing the weight for a specific entry makes that particular foliage type more prominent in the scattering process. Experiment with adjusting the weights for each array entry to find the optimal combination that achieves the desired visual aesthetic for your grassy area. This flexibility enables you to fine-tune the appearance of the landscape based on your preferences. Let's change the crossroad type to a combined lane type crossroad and observe how the PCG adapts to these alterations in road structures. As seen, some adjustments are needed to correct the scattering on the double lane roads. To address this, select the double lane roads, type tag into the search bar of the road settings, and add an additional tag array with the parameter for instance wide road. Let's do it for both double lane roads. These tags function as variables that define specific properties in the PCG graph. Before making further adjustments, let's enhance the organization of the PCG graph by grouping related nodes together and adding comments for clarity. Group relevant nodes together with comments by selecting nodes and pressing the C key. Name the groups to reflect their functions, such as single lane road. Let's group the nodes related to the crossroad setup as well. Copy and paste the single lane road nodes, connect them with the difference node, and rename this new group as double lane road. In the Get Spline Data node within the double lane road group, change the tag from road to wide road. Lastly, adjust the road width in the bounds modifier node, changing it from 280 to 560 in both directions. These modifications ensure that the PCG system correctly handles the wide road variations and maintains the desired road widths. When modifying the road shape, the PCG system recalculates the scattering around the road structures. It's important to note that when adding new road elements, ensure that the correct tag variable is assigned to maintain correct functionality. If you activate extra modules on the Crossroad, the PCG will consider them and adjust the scattering accordingly. However, if you incorporate additional modules on the road, such as curbs or sidewalks, you may need to edit the bounds modifier nodes of the road to offset scattering and prevent interference with the sidewalks. This approach serves as a demonstration of one way to handle specific situations, showcasing the adaptability of the PCG system to different elements and configurations in the environment. Let's add an additional layer of foliage, this time some trees. We can leverage our existing nodes for an efficient setup. Begin by copying and pasting the nodes responsible for grass scattering. Group these copied nodes with a comment labeled Grass for reference. Now, let's reuse the same nodes to scatter trees. Group pasted nodes with a comment called Trees. Temporarily remove the mesh entries arrays, as we'll replace them with new arrays specifically for tree meshes. Reset the points per squared meter value and point extents value in the surface sampler node by clicking on the small arrows icon located on the right side of each parameter. Upon activating debugging at Transform Points node, you'll notice that the future trees are scattered across the entire area, including the crossroad with roads. To exclude the road system from tree scattering, we have to copy and paste only the bounds modifiers related to the crossroad and roads. This step allows us to have a separate control over the spawning positions for trees and grass, ensuring that the foliage is distributed as intended. Let's reconnect all nodes and fine-tune the bounds modifier minimal and maximal values to achieve a more realistic offset for the future trees from the roads. This adjustment aims to replicate how trees would naturally be positioned in a real-world scenario. To achieve a less dense scattering of trees across the area, insert a self-pruning node after the Transform Points node. This node will assist in reducing the number of trees randomly, resulting in a more natural and visually appealing outcome. Finally, reconnect the static mesh spawner node to replace the debugging boxes with actual tree meshes. Add a few tree variations to the spawner node by dragging and dropping tree meshes into the descriptor section. The tree meshes used in this demonstration can be sourced from the Unreal Marketplace or are part of the Quixel Megascan Library, providing high-quality assets to enhance the realism of your PCG setup. Let's turn off the debugging mode for the self-pruning feature on the node. Now, let's expand our road system a bit to see how the PCG adapts. We've set up a small street map with a few houses and a road bridge for testing. Applying our PCG setup to this map is easy. Just select the PCG actor in your editor and hit the cleanup button. This temporarily removes the foliage from the landscape, boosting performance for adjustments. Now, move the PCG actor and use the transform parameters to scale it up, covering the entire targeted area. After scaling, click Generate to recalculate foliage scattering. Take a closer look at the result. It's looking pretty good. However, we've got a few issues to tackle. Buildings are getting in the way of trees, and the road bridge has some tree interference. To fix this, let's make adjustments in the PCG graph. First, temporarily disable foliage spawning by turning off the surface sampler node for grass and trees in the PCG graph. This makes adjustments easier and helps us visually debug to see what's happening. Head back to the editor and choose the road bridge. In the search bar, type tag and add another array with the variable named bridge. This helps exclude the bridge from scattering. In the PCG graph, add a getActorData node. Set it up by choosing all world actors in the actor filter, keeping actor selection as by tag. Replace none with bridge in the actor selection tag, and make sure to enable select multiple. Connect this node to the volume sampler node and enable debugging. The white areas will be excluded from scattering. Let's turn on the trees again to see the result. Connect the volume sampler node with the difference node and enable tree scattering. Some trees have been removed, but we need to trim more. To achieve this, we have to add additional nodes to outline the outer borders of the bridge structure. Add the getSplineData node. Set it up by choosing all world actors in the actor filter, keeping actor selection as by tag. Replace none with bridge in the actor selection tag, and make sure to enable select multiple. Add the spline sampler node. Set subdivision per segment to 10 in the spline sampler node. Lastly, add the bounds modifier node, enable debugging, and set the mode parameter to include. For now, set any bounds values to see changes in the editor. Connect this node to the difference node. By adjusting the minimal and maximal bounds parameters, you can trim trees near the bridge. Disable debugging on the bridge to see the final result. Now there are no trees in the way of the bridge. Feel free to experiment with the bounds values to fine-tune the desired appearance. Apply the same method to buildings or any other assets you incorporate into your scene. This workflow is highly flexible and practical since it allows you to generate numerous variations quickly. The automatic adjustments take care of the heavy lifting, and you only need to tweak specific details if necessary. This eliminates the need for manual asset placement, potentially saving you countless hours when crafting visually appealing levels. Thank you for watching this 7th chapter video tutorial. To delve deeper into Crossroad Generator capabilities, I encourage you to explore all the tutorials available on our YouTube channel. If you're seeking to elevate your environment and create stunning scenes, the Crossroad Generator for Unreal Engine is an indispensable tool. You can find it on the Unreal Marketplace, and the link is available in the video description. Thank you for watching, and don't forget to render your tale with us.